Hello, everyone. Welcome once again to another discussion of critical reasoning. In this module, we are going to be focusing on causal arguments. So, this is a continuation of our discussion of inductive reasoning more generally, but specifically now, the form of inductive reasoning that we are going to pay attention to is relates to causal arguments and causal reasoning. You'll find all of this material in Chapter 9 of the Vaughan text. And as I've mentioned before, I highly recommend that you use the handout and take notes and so forth as needed. It's available for you online to follow along with. But all this material comes straight from Chapter 9 from Vaughan. So let's go ahead and jump right into things. So first of all, I want to explain what we mean by causal explanations. Like, what is a causal explanation? Generally speaking, a causal explanation, at least for the purpose of this class, is going to be an answer to a why question or an answer to a how question. So, for instance, we might say, why were you late to the meeting? And the answer to that question would be a causal explanation for why you were late to the meeting. Maybe your car broke down, or maybe you overslept. Another way we can think about this is a how question, like how did you get here today? And the answer that you might give, like maybe you rode your bike or maybe you took the bus, that would be a causal explanation for how you got here to the meeting or wherever you happen to be. And so these causal explanations involve what we might call a causal claim or a causal statement. And that's simply going to be any sort of a truth apt statement that involves some sort of a causal relation, something that's causal at work within that statement. So the example I provided here is I was late because my car broke down, or I got here by walking. So that's a statement that's truth apt. It's either true or it's false, and it involves some sort of a causal relation or some causal work, some causal power that's involved here. And so causal arguments generally are inductive arguments because the conclusion contains some causal claim, right? And remember that we're working with induction. So we don't have a guarantee of the truth of the conclusion like we would in a deductive argument and deductive reasoning. Rather, it's possible that the conclusion could be false while all the premises are true. So that's what makes it an inductive argument. But here it involves some causal claim, right? The conclusion involves some sort of causal work or causal powers, we might say. And oftentimes, these sort of arguments, these causal arguments, are very, very helpful and influential in scientific inquiry, reasoning, scientifically speaking. And this is going to be really important for us when we turn our attention in a couple of weeks and in future modules to a discussion of scientific reasoning more generally, and the scientific method itself, because we have a number of different kinds of explanations and inferences to different explanations that will be important when we get into that material. But for now, we should consider these causal arguments as applying to scientific inquiry when we're concerned primarily with the causal process, right? Or the whatever seems to be commonly deployed as a causal element in the argument or in the reasoning that's involved. So, a causal argument then can come in various different kinds of forms. We've already seen previously how this can happen with enumerative induction as well as analogical induction. And in future modules, we'll also consider inference to the best explanation. So those are some of the main ways in which we find causal reasoning, causal arguments deployed. The next thing I want to turn our attention to is this idea of what we call Mill's method. Mill's method is straightforward. Basically, it's the method of inductive inferences that's commonly used in most scientific reasoning, right? So there's the method of agreement, and Mill's method of agreement tells us that if two or more occurrences of a phenomenon have only a single relevant factor that happens to be in common, well, then that factor must be, in some regard, causally efficacious, right? There's some sort of causal work that's happening, some causal power that's involved. So that's the method of agreement. When we have two or more occurrences of some phenomenon and they only have a single thing in common, well, then that single factor must be, in some regard, causally efficacious. But there's also Mill's method of difference. Here, what we have is we are paying attention to the relevant factor if it's present when the phenomenon occurs, but it happens to be absent when it does not occur. Well, then that factor must be causally efficacious, right? Because it's happening when it's occurring, but it's absent when it's not occurring. Then that seems to suggest that there's something going on there. It's doing some work. There's something pushing and pulling or some power at work here. And then finally, we have a what's called a joint method, Mill's joint method of agreement and difference. So this is the application of both the methods of agreement as well as difference simultaneously. Right, doing so will actually generate a kind of increase in the probability that the relevant conclusion is true. Right? So it will actually increase the likeliness that the relevant inductive argument is cogent. Right? So how are we going to do this? Well, we can consider different steps that we can take to figure out these different methods. Step one, we identify the relevant factors that are common to the occurrence. This is the step of agreement. And then step two is when we discard those factors that are present when there are no occurrences or are no differences. So let's consider an example. All right, so this example, this entire discussion occurs on page 185 through 187. This specific example that I'm going to read for you comes from the bottom of page 187. All right, so this is the bar example that I'm suggesting here. So what the text says here, what Vaughn says is, let's apply this combined method, the method of the joint method of agreement and difference. Let's apply it to the mysterious illness at Elmo's bar. Say that among the 10 patrons who become ill, the common factors are that they all drank from the same bottle of wine. And let's say they all had the free tacos. So we reason that the likely cause is either the wine or the tacos. That's the thing that's in common. But after further investigation, though, we find out that the other patrons who ate the tacos did not become ill, right? So everybody who became ill ate both the tacos and drank the wine, but there was a bunch of other people who ate the tacos and did not become ill. So that's the method of disagreement or difference. And then we conclude that the wine must be the culprit. The wine is what's responsible for making these folks ill. So maybe you can think of other sorts of examples. Maybe you could consider the sorts of studies that are being done. Maybe studies on vaccinations, or perhaps different studies that pharmaceutical companies are investigating. So these are the sorts of things that I want you to attempt to think of your own sorts of examples. Now, the next point I want to raise is this point about correlation. Right? This is a relationship or a connection between two or more things or two or more factors. And in the process of inductive reasoning, it involves establishing that sort of relationship or that sort of connection between two or more things or factors or measurements or whatever it might be. But notice that correlation is not the same thing as causation, right? We need to keep this distinct in our minds. But clearly, it's helpful to think about this notion of correlation as it relates to Mill's method, method of agreement, method of difference, and then the method of agreement and difference, right? So we'll come back to this point about correlation here momentarily. Now, another aspect of Mill's approach to causal reasoning here is what we're calling Mill's method of concomitant variation. And here, the term concomitant just simply means associated, right? This sort of association or correlation, right? So this method says that if two events or properties or factors or whatever are correlated, such that one varies in association or close connection with the other, then they are probably causally related or in some sense likely to be connected. Right? So this kind of inductive reasoning is very, very common, especially in medicine and physics, where we're attempting to directly identify the actual cause and the effect. But that can be very difficult. But again, as I mentioned a second ago, we need to be very careful, right? The correlations are only indirect evidence. Having a correlation is good, it's helpful, but it's only indirect evidence of cause and effect. It's not going to be immediately clear in every situation, right? So we need to be careful not to conflate cause and effect with mere correlation, right? The slogan that is oftentimes presented here is correlation is not causation. It's not necessarily the same thing. So I want you to think about different examples, especially these sorts of examples that might show up in medicine or physics, as well as examples where there is a correlation without any causation. All right, so the next thing I want to dig into here is this aspect of misidentifying different relevant factors. This certainly happens both in enumerative induction as well as with regard to background information. So we saw in the module last week that there may be situations where we're working with enumerative induction, but we've got a biased sample. Or when we're working with enumerative induction, we've got maybe there are issues that have not been taken into consideration, or perhaps our sample size is too small. All sorts of different ways in which we can misidentify the relevant factors with enumerative induction. In fact, this does happen with analogical induction as well, where maybe it looks like we've got a good analogy, but when we dig into things a little bit deeper, it turns out that there's disanalogies that we need to pay attention to. But there's also ways in which we can misidentify relevant factors that are based upon the background information that we have. So here's what Vaughn says on page 189 in regards to the background information that's going to be relevant. Vaughn says your ability to identify relevant factors depends mostly on your background knowledge, what you know about the kinds of conditions that could produce the occurrences in which you're interested. So, lack of background knowledge might lead you to dismiss or ignore relevant factors, or to assume the irrelevant factors must play some sort of a role. The only cure for this inadequacy is deeper study of the causal possibilities in question. Right, so that's why we need to pay attention to the nuances and the complexities that are involved here. Otherwise, we're working with a limited amount of information, and that could either allow us to ignore certain factors or to misidentify them in some regard. Now, there's also a problem of having too many or too few factors, right? There's going to be some cases where there are just way too many potential relevant factors to identify just one factor. Think about the way cosmology works, right? When we're talking about gravity, for instance. It's not really quite correct to say that the reason why the moon rotates around and orbits the Earth has to do with the mass of the sun and the mass of the Earth. That's true. Those things are relevant factors, but there are way more factors than that. There's all the other planets, right? So the mass of Jupiter is much, much more massive than the mass of Earth and the mass of maybe other stars that are in other parts of the galaxy, right? There are lots of different things that could be playing some sort of a causal role, way more factors than what we can actually identify. So that might be a situation where there's too many potential relevant factors, and that's actually why we try to zone in on the most relevant factors, right? So the most relevant factors being the mass of the Earth and the mass of the Sun. But then there might be other cases where there are not enough relevant factors. Maybe that's due because of our lack of some kind of understanding in the particular issue that we're dealing with, or some kind of insufficiency with regard to background knowledge. And maybe that's actually due to some cognitive bias. And that could be potentially what's gone wrong in our ability to identify just the right causal factor. So, to help think about this, let's consider coincidence. So, for instance, Jones thinks that the number 333 must be really significant because they always see it on the clock and other places too. But it's not very unlikely, right? Just because Jones happens to see this 333 number all the time doesn't mean that that's something that should be unexpected. In fact, arguably, Jones will see 333 at least a few times maybe even more throughout the day, especially if it's the case that Jones has really kind of gotten himself into the habit of seeing this number all of the time, right? If he becomes sort of accustomed to noticing this number, almost to the point where he's expecting to see it, well, then it's probably going to be very likely that he will see it at least a few times every single day. So the number probably isn't really that significant altogether. Rather, it's likely is that it's just a mere coincidence. Now, I think it's likely that the a very good reason why this tends to be the case is because people are really quite bad at probabilistic thinking. There's two different examples here that I've given you, and I'm going to provide some videos for you to watch as well on both of these examples. But these examples, I think, do a really nice job of demonstrating how bad we human beings actually are when it comes to statistical or probabilistic thinking. So this involves the gambler's fallacy. Also, sometimes it's called the sunk cost fallacy. And then another very, very famous sort of mathematical problem or dilemma here is called the Monty Hall problem. So I want you to watch both of these and pay attention to them, especially as they illustrate this point about just how bad we are at probabilistic thinking. But that's not necessarily a bad thing, right? Human beings have a tendency to see patterns in random information, right? Some psychologists have actually speculated that this so-called error actually does a nice job of explaining why we are so misled by coincidences. In fact, we are actually pattern-seeking primates. It is actually kind of hardwired into us by evolution, right? It's a part of the way that nature has constructed our minds that we do find patterns even when there are no patterns there. We infer that there's patterns from a causal relation, even if there actually is no causal relation there. And this is to our benefit. This is helpful from an evolutionary perspective. All right, now the next point that I want to turn to is this point about confusing causation with temporal order. Sometimes philosophers use this Latin phrase, post hoc ergo propter hoc, which basically just means after that, therefore because of that. And so this is the basic problem of confusing causation with some sort of temporally structured order. Right? So we tend to think that a cause must precede its effect. Right? Just think about the example of a cue ball when you're playing billiards balls, right? So you hit the cue ball first, and then the cue ball strikes the eight ball, and then the eight ball goes into the corner pocket, right? So we think that there's a causal relation here because of the temporal order in which these events occur. But the mere fact that, temporarily speaking, something occurred first or prior to something else, it does not automatically mean that it caused the other thing. Here's some arguments to help you think about this. So the first argument says, after training for police officers was enhanced, violent crimes in the city decreased by 10%. So enhanced training caused the decline in violent crimes. Well, that's not necessarily the case. Just imagine something like with the pandemic when there was a whole bunch of shutdowns. And so nobody was going outside and nobody was, doing much of anything. It was just like this kind of a lockdown period. Well, maybe the police officer training was enhanced a few months beforehand, but then there was this lockdown due to the pandemic. So there was a huge decrease in violent crime. So clearly, in that case, we would want to associate the causal factor to be the fact that people were, locked up inside of their homes and there was a pandemic going on in society, right? That seems to be much more causally efficacious in this example. So just the mere fact that the police officer training was enhanced, temporarily speaking, prior to the drop in violent crime doesn't automatically mean that it's causally efficacious. It might have some relevant factor, some relevant causal work, but not necessarily. We got to be careful here. Now, the second argument says, an hour after Julio drank the cola, his headache went away. The cola must have been what cured his headache. I think this is sort of an interesting example because oftentimes people do associate with the kind of fizzy carbonation. I mean, I certainly do associate with that kind of carbonated fizziness to help maybe having a hangover or having some headache, right? But the mere fact that you drink the cola doesn't necessarily mean that that's what caused the headache to go away. The mere fact that it came first and then the headache went away. Maybe you also took some Tylenol or some Advil, and that's actually what made the headache go away. The third argument here says, as soon as Smith took office and implemented policies that reflected his conservative theory of economics, the economics went into a downward spiral characterized by slow growth and high unemployment. Therefore, Smith's policies caused the current economic downfall, right? Well, again, the mere fact that these conservative policies went into place first doesn't necessarily mean that that's what's to blame for this calamity, this economic disastrous event. Maybe what actually caused it is, I don't know, or maybe it's Trump's tariffs. Maybe that's what's doing the causal work in this example here. So argument four says, I wore my black shirt on Tuesday and I got an F on the math exam. I wore the same shirt the next day and flunked my psych exam. That shirt's bad luck. Well, the mere fact that you wore the shirt before this other thing happened doesn't mean that's the thing that caused it to happen. A much better explanation for why you got an F and on the math exam is because you didn't study for it or something else. Ditto for the psych exam. So I want you to think of some of your own examples to try to help get a sense of how we might confuse causation with mere temporal order. Again, post hoc ergo proper hoc, right? After that, therefore, because of that. So now let's move on to this point about. Um, so now let's move on to what I'm calling a rule of thumb for thinking about causal connections. The idea here is you shouldn't just automatically assume that there is some causal connection, that some causal connection exists, unless you have some really good reason for doing so. But of course, this raises the next question. What will count as having good reason for thinking that a causal connection actually exists? So one thing we can do is we can consider necessary and sufficient conditions. The necessary conditions would be the conditions that are relevant features that a thing must have in order for that thing to be the case. Right. So for instance, if I am buying a coffee from the coffee shop, and let's say the coffee costs $3, well, I have to give them at least $3 in order to purchase the coffee. That's like a necessary part of getting the coffee. Or the example that I've given here on the handout says the presence of oxygen is a necessary condition for combustion to occur. If you don't have oxygen, if that's absent, then combustion is never going to occur. But we can also consider different sufficient conditions. These are going to be the conditions or relevant features that are involved that are enough to guarantee that something exists or that something will be the case. The example I've given you here is having all the right necessary conditions, oxygen, heat, fuel, so on and so forth. These will be sufficient for the combustion to occur. Or if you consider the example from before, when I purchase a coffee, uh, which costs, let's say, $3, well, I could give them a $5 bill. That would be sufficient, but not necessary. I could give them a $10 bill. That would be sufficient, but not necessary. I could pay with a credit card. That would be sufficient, but not necessary. I could give them a whole bunch of pennies. That would be sufficient, but not necessary, right? So here the idea is any one of those examples would be enough to purchase the coffee. And the necessary conditions would just be having $3, whether that be because you have five or because you have 10 or because you have a credit card or what have you. Now, the last thing that I want to bring to your attention before we move on here is sort of a teaser regarding Hume's problem of induction and causation. Notice that it's not obviously true that appealing to some alleged necessary or sufficient condition is always going to be a good guide to believing that a causal connection, in fact, does exist. In order to spell that out in more detail, I want to consider and say a bit more about what's sometimes called Hume's problem of induction and Hume's skepticism about causation and necessary conditions. So in the next video, I'm going to give a brief overview of these different aspects, but I've also included some other more detailed videos to talk about Hume on the problem of induction, causation, and necessary conditions. So that's what we're going to look at in the next video.